So that's pretty much how these problems work. I'm gonna see if I can do a couple more with you. Let me just separate the problem I just did, and I'll start a new one. Okay, let me bring these down here. Okay, so again, I'm gonna attach this table to every problem because I think it's really helpful to see how you can convert it. So our second problem is gonna look like this. So we have 32 to the 3x minus 3 is equal to 8 to the x minus 1. And so again, we're trying to figure out where these numbers are in our table, and remember that they have to be in the same column. So we're looking for the section that has the same numbers. So let's see. In this column, I don't see a 32. I do see a 32. So if I look right here, I see a 32. Oh, look, and right there I see a 8. So bingo, bingo. The moment that you see both of them in the same column, that's all you need, because you just need a common base. So the common base here is going to be 2. Oops. 2 to the third, 2 to the fifth. Okay, so let's go back to the problem. I'm going to rewrite this as something to the 3x minus 3 is equal to something to the x minus 1. So how am I going to get the something? Well, I noticed from my table, another way to say 32 is 2 to the 5th power. So I'm going to come back over here and write 2 to the 5th power. And then another way of writing 8 is 2 to the 3rd power. Okay, so now you notice that you have a common base. So that's what we meant by the title, which was a common base. This. Okay, so that was step 1. Remember, step 2 is to apply the power rule. So apply power rule. Power rule. So remember the power rule. If we have power to another power, we just multiply those two powers together. So I'm going to apply it on this side. If I do it over here, I get 2 to the 5 times 3x minus 3. If I apply it to this side, I get 2 to the 3 times x minus 1. And so again, notice that you have common base. So that highly simplifies our problem, and we can pretty much get rid of those bases and only focus on the exponents. So that goes away. So my problem becomes 5 times 3x minus 3. Let me write, that's fine, is equal to 3 times x minus 1. So again, I can go ahead and distribute. That'll be 15x minus 15 is equal to distribute 3x minus 3. All right, and then again, we're pretty much solving this like 8th grade, 9th grade equation solving. So here's my like terms. I see a 15x and a 3x. So I'm going to go ahead and move. I typically like moving the smaller one over, but it's really up to you. It doesn't matter. So again, this one goes away, or becomes 0, I guess I should say. So this is, way too big. So this is 12x minus 15 is equal to negative 3. Then I see another pair of like terms. So I'm going to bring this 15 over. Then these will cancel. Oops, those will cancel. And then I am left with 12x. I think that's a little too big. Then we're left with 12x is equal to 12. Oh, look at that. So if I want to isolate this x by itself, I need to get rid of this 12. And that just becomes 1. Right? So I pretty much get x equals 1. Because 12 divided by 12 is also 1. All right. And then again, we can do a quick check if we just want to know for sure that we're doing it right. Our initial equation was 15x minus 15 is equal to 3x minus 3. If I erase the variable, oops, not all of that. If I erase the variable and in its place put 1, let's see what happens. So this would be 15 minus 15 is equal to 3 minus 3, and it just so happens 0 is equal to 0. So it does check. All right, so I hope you're kind of getting the hang of this. I'll do this last one, and hopefully it'll stick after that. If not, hopefully you can make time for some office hours. Okay, so our last example like this is 9 to the 2x plus 4 is equal to 81 to the 3x minus 4. So again, right now my bases are 9 and 81. So I'm going to my table and I'm like, where's 9 and 81? So I don't see 9 or 81 there. I don't see 9 or 81 there. Oh, look right here. 9, 81. So another way to say 9 is 3. Oops, a little too big. Another way to say 9 is 3 to the 3 to the second power, sorry. And another way to say 81 is 3 to the 4th power. So let me go back down here. Let me write the equation. 9 to the 2x plus 4 is equal to 81 to the 3x minus 4. And again, the whole point is to rewrite both of these with a common base. Right now, the bases are not common. This is 9 and 81. But using the table, I see that I can rewrite it as something to the 2x plus 4 is equal to something to the 3x minus 4. And according to my table, another way to say 9 is 3 to the second power. So I'm going to go over here and write 3 to the second power. And another way to say 81 is 3 to the 4th power. So I'm going to go ahead and write 3 to the 4th power. Then, now that I have them written with common base, so now they both have 3, we're good to go. So I can apply power rule. Again, power rule says if you have power to another power, just multiply them together. So this one would be 3 times 2 to the 2x plus 4 is equal to 3 times 4 to the 3x minus 4. Again, we see the common base with different exponents. So this, we don't really need the base anymore. We just focus on the exponent. So my problem becomes 2. My problem becomes 2 times 2x plus 4 is equal to 4 times 3x minus 4. I'll distribute. 4x plus 8 is equal to 12x minus 16. Find the like terms. I see 4x and 12x. Again, I typically like to move the smaller one. Cancels, so I get 8 is equal to 8x minus 16. Now, these are like terms, so I'm going to move 16 over, and then I get 24 is equal to 8x, and if I want the variable to be alone, I will divide by 8, and that'll give me 3 is equal to x. So again, if you really feel confident and trust your algebra, go for it. I still recommend checking your answer. So I'm going to do a quick check. And our original one was 4x plus 8 equals 12x minus 16. Again, wherever those variables were, I'm going to get rid of those and replace them with 3. Let's see what happens. Here would be 12 plus 8. That gives me 20. So I'm really hoping this side is also 20. This would be 36 minus 16. Well, look at that. It ends up being 20. So it does work. Yay. Okay, so I'm hoping that those 3 examples will help you get through your Delta Math examples. They'll be pretty much like that, and I'll put this table up for you to use as a reference.